Hello, my name is Mayeda, and welcome to State of Virtual Production. So we have a bunch of cool updates on the film and TV world to share with you, and we'll start with in-camera VFX. So the big ticket item for ICVFX here in the 5.6 release is that we're introducing support for NVIDIA's DLSS algorithm with NDisplay. So the way that's going to manifest itself is that in the NDisplay settings, there's now an upscaling method option. And so by default, this will use TSR, but you'll be able to switch between all the different modes explicitly, right? So instead of TSR, you can also now switch to DLSS if you have that plugin enabled. And then this will then be based on like the different quality settings that DLSS offers. So in practice, what this means is that option is always going to be available for operators. So you can always use TSR or default, what you've been using, what you're accustomed to, or NVIDIA DLSS if you prefer. The mileage is going to vary on a scene-by-scene basis. It's something that we'll be able to share some clips like coming up here, but like that's just something to be aware of, right? So sometimes DLSS may work better, sometimes TSR may work better. And really, like the operator control is key, right? So when we looked at how to do this feature, we just wanted to make sure that operators have the flexibility to go back and forth, and this applies to both the outer viewports and the inner frustum. Another thing to be aware of is that this requires an update to the DLSS plugin, right? So typically, NVIDIA will do an update to that plugin for each Unreal release. So while like UE56 is out, the DLSS plugin is still on the way, right? So like the feature on the Unreal side is contingent, of course, on the DLSS update. So we've been working with NVIDIA on these changes, and so hopefully they'll be out pretty soon. I'm expecting there'll be a nice announcement from them pretty shortly. Another thing to be aware of is that we're mainly testing upscaling. So DLSS has other features like ray reconstruction and frame generation. And that's something that will come along later, right? So as NVIDIA gets their updates for 5.6, we're going to keep working with them to try these other DLSS features. And we'll probably follow up with like some sort of post online that just shares the findings, both like if it works or not, and then also like what's good or bad about them visually. Another thing to be aware of for operators is that people are generally pretty accustomed to manipulating screen percentage to tweak quality versus performance, and that's still going to be the case with DLSS, but they now use these names, right? So the named quality settings for DLSS, they equate to screen percentage equivalents in Unreal, right? So the ultra performance option is 33%. The performance option of DLSS is 50%. There's a balanced option at 58, a quality option at 66, and then the full 100% is called DLAA. So like for any of the operators that are accustomed to punching in these numbers, when you see those names in the DLSS menu, that's what they equate to. And so like you will still technically be able to change the screen percentage to something else, but it kind of just rounds up to basically like whatever you're closest to. And so that's why in the settings, like they'll just be toggles. Like you won't have to punch the numbers in anymore. When you're using DLSS, you're going to put yourself in the mental model of the settings that they offer. So here's a few shots that we filmed on our stage, right? So this is starting to test it out. So on this saloon piece, this is an example of a shot, a section of this saloon scene that we shot with TSR. And so the area to draw your attention to is this area right here, right above that little landing, walking into that building, right? So if we watch it again in loop, you'll see there's like a little bit of flickering. There's some artifacts that are probably not going to be super desirable for you in the context of shooting this shot. And then if you switch over to DLSS, you'll find that that area calms down a little bit. So this is an example of where as an operator, you might want to try both and see if you're getting better results for a particular scene. Another example is in the city, right? So this is an example shot of us kind of driving through the city. And the area to call attention to with TSR is you can kind of see those hot spots at the bottom of the window on the left side. We'll let it kind of run through, but you can see those there on the edge of the sidewalk and the windows. But switching over to DLSS, like those artifacts go away, right? So this is an example of where you may choose to use DLSS on this particular scene for this particular shot, and likewise, like your operator is going to be able to choose. It's just a single click to go from one to the other. On the flip side, this is another example where like you may get the opposite result. So like we'll kind of call your attention to this area that I've highlighted with a line. And for some reason on this particular scene with DLSS, you're going to get this like solid, noisy line that just goes all the way horizontally across the screen. And this goes away with some of the other settings or switching over to TSR. But it's an example of where, like, with NVIDIA's DLSS system, like, you kind of, it wants you to just be, it's very simple. You're just going to get what you get from it. But in the case where it's something that's undesirable, you'll be able to switch back and forth. Also, on the display side, we've introduced the failover feature. Actually, this feature has been around for a while, but there are some improvements that we've been working on. And in particular, in 5.6, you'll be able to fail over the primary node. So, like, typically you lay out your stage. You have n number of render nodes running all of the viewports. But if there was potentially like a hardware failure or something were to go down, right? So you're able to have these backups that are also part of the cluster and basically ready to go in case anything happens. So if any of the nodes were to catch on fire, right, hopefully this will not happen to you in real life. But if you have these backups ready to go, you can slide them in, and the cluster will stay up. Also in 5.6, we've added support for OpenTrack IO. So for anybody who's been following the OpenTrack IO standard, Epic as a whole, we remain really committed to supporting these open standards. And OpenTrack IO is a relatively new one that's focused on camera tracking, lens encoding, and metadata. And so in 5.6, we now support this standard. So any camera or any tool that supports OpenTrack IO, that'll kind of automatically come along for the ride as a live link input. So we've started this process with Sony. So this is some clips of some action-packed clips of us testing testing this out with Sony. So they've added support for OpenTrack IO to the FR7 camera. And so this was the first camera that we tested and validated the OpenTrack IO integration on. So going forward, anything that's supporting OpenTrack IO, that can kind of come along for the ride for free as an Unreal Engine input. Kind of last but not least on the ICVFX side is continued updates to SIMP 2110, right? So we're seeing production starting to use SIMP 2110 like on real shows, which has been great. It's also found some problems or some improvements that we need to make just for stability as everybody updates to this kind of new platform. In 5.6, we had GPU direct support, and this is something that I actually, as a confessional, I had confused at first, right? So when you think of GPU direct, you're like, what is it? It's obviously better, right? Direct is much better than indirect. But the thing that I always thought about it was well, if it's GPU direct, that's going to improve latency, and that's not necessarily true or the actual benefit. So what ends up happening is that because the transfers are direct from GPU to GPU, it actually reduces the amount of work that the GPU has to do in terms of copying data back and forth from the system. And so that frees up the GPU to do more work. It gives you a little bit more budget in terms of the performance of your scene, and that's why it helps things. Another question we get a lot is about BlueField 3, right? So we have not been able to get BlueField 3 cards ourselves, so that's just an update that we're aiming to get out to people soon, right? So over the course of the summer, we should be upgrading our systems to BlueField 3. We can get that validated. And I know for some of the stages looking to update, the BlueField 2s are kind of going away, and there's some questions about just people want to hear that the BlueField 3s are confirmed. And so that's something that we're going to be working out over the summer, and we'll probably do a post or something that just kind of just advertises our findings. I think we expect it's going to be good, but we just want to make sure we're dotting our I's and crossing the T's. Looking ahead to 5.7, so I have always viewed live compositing as kind of in-camera VFX, right? It's part of getting VFX style shots in camera and live. And so as part of this, we're revisiting the suite, our set of live compositing tools, and that includes our old friend the composure sample, right? So being able to do these types of shots in a more scalable and easy way in kind of a modern Unreal Engine, right? So these shots are still informative. They're still the types of shots that I think people want to be able to do live. And we've been hard at work, basically trying to augment the foundation to be able to support this better, right? So you're taking a shot like this, where you have the background. You want to be able to render some sort of character or have some CG elements. You're going to want good shadows and reflections as part of it and be able to comp it back in. And so that's kind of going to be manifesting itself in 5.7. We've been spending a lot of time with the virtual production dev team and the rendering team to get performant shadows and reflections. As part of this, we're revisiting the way the tools workflow is. We need this to be an easy-to-use setup. This will also include a simplified media I/O setup, right? So fewer assets, being able to say, like, I want to, bring in my camera feeds here, I want to send them out here, having that all be a consolidated experience that's easy to set up and repeatable and reliable. So that's something to look forward to. Switching over to performance capture, this is a clip that I just felt like we needed to show of my colleagues testing out the system. But there's a bunch of stuff coming for performance capture in 5.6, right? So this was referred to in the, you saw this in the keynote, right, with Corey and Matt Workman. But the MetaHuman animator now has real-time capture, and that's all through LiveLink Hub. And so LiveLink Hub is like our contribution to it virtual production-wise was this LiveLink Hub aspect. This is now acting as the way to bring that MetaHuman animation data in live. On the tool side, we've invested really heavily in a mocap manager like suite of tools, right? And so this is something that's really meant like in the same way that we have the in-camera VFX editor, things that are really focused for the operator on an LED volume. Same thing goes for like the operator on a performance capture stage. So there's a whole bunch of tools consolidated in this little window that helps provide a nice experience and without having to click around or have a whole bunch of windows open for the person running the mocap stage. Like some specific callouts are for retargeting and props, right? So this is consolidating how you manage the way the retargeting is set up as well as your props. There's a way to visualize what the retargeting is. You can quickly toggle through and set up props, like all in this one mocap manager window. We've also introduced a take recorder subsystem. And so what this means is that you are able to have other tools run take recorder, right? So in this case, it's the mocap manager, but it could also be your own like blueprint, editor, utility widget, whatever. And so what's happening is here, you can see you have your own take recorder window. You don't necessarily have to have the big take recorder window up. And you also don't necessarily have to have sequencer up if you want to do recording. So like this gives you as an operator more flexibility both to have the windows set up the way you want, and especially if you're building tools, especially those that involve recording, gives you more flexibility and control over how you actually build it out. For a deeper dive, you can go to Richard's talk, which actually already happened, so you already missed it. So you're just going to have to catch it on YouTube. It was yesterday. But he goes into much more depth on this. So it's a full talk, and he goes through each part of the mocap manager. So for anybody that's interested in performance capture or motion capture, it's definitely worth checking out on the internet. So previously on State of Virtual Production, we were having some existential questions on what shots are, what is the meaning of a shot, at least as it relates to Unreal Engine. And so in 5.6, we have some findings. We have the beginning of some tools and some offerings related to this. And that's going to be called the Cinematic Assembly Tools, or CAT. And so what we found for shots is that shots are many things, and that requires a whole bunch of tools that add up to like a more cohesive shot experience. So that's starting to come out in 5.6. So what does that mean? There'll be a set of different things. So an example of this is naming tokens. So in naming tokens, this will allow you to define reusable naming tokens to set up strong naming conventions for your project. So there's ways to customize them, and then your tools in C++, Python, et cetera, will be able to leverage them. There's also a production wizard, and so this will allow you to define and reuse settings like across projects, right? So you have one project, everything's set up correctly. You start another project, you want it to be the same. That's not necessarily as easy as you might think, and so the production wizard is going to help facilitate that. We also have the ability to pre-populate folders. This may sound simple, but like in general, like artists will probably put something in the right place if the right place already exists. And so in conjunction with the naming tokens, you're able to pre-populate folders that maybe are for your shot data, for example, and that incentivizes people to put things in the right place. And then kind of last but not least are asset naming defaults. So using the tokens, you're able to define these like conventions that say like based on a particular type of asset, you could control the naming. So like when you say new material, it's gonna start giving you a good name or at least a convention that you want, and then the artist can fill in the rest. These are seemingly small things that help keep the project tidy and organized. Hopefully it'll be more effective than just asking them to name it the right way. You can still do that, but this will help them do it in practice. Building on those kind of baseline items is the actual cinematic assembly schema. So we're starting to get into more of the higher level tools that the team has been working on. And the schemas allow you to define entities, for example, a shot, and then create templates for them. As part of this, you can specify the folder structure, and that includes subsequences. So like if you're creating shots, you always want them to have certain subsequences. That can all be defined as part of the schema. You can give it a custom icon, for the visual people out there. And then once you've defined the schema, you can create the assets, right? So this would be potentially like your shot asset. This can store pipeline metadata. It will always open shots in the right level. I don't know if you've ever tried to do this, where you open a sequence and you don't know which level it goes to. This is aimed at solving that problem. As part of this, kind of tying it together, we're again just reiterating this thing that folders and setups are always in the right place. It has metadata, as an example of metadata, you can add notes. And all of this data is accessible through Python and blueprints for tooling purposes. This is another plug, right? So this is one that you have not missed yet. So if you're still here tomorrow, you should definitely check out Thomas and Jeffrey's dedicated talk on this. So they're going to go deep into the world of shot pipelines and also give you some dating advice. So if you need either of those things or both, highly recommend checking their talk out tomorrow. Now we'll switch over to rendering, right? So a number of rendering improvements were mentioned in the keynote, but there are a couple I just wanted to highlight that weren't specifically mentioned that I think are applicable to the film world, right? So the first has to do with depth of field. And so on the rendering side, the depth of field has some new enhancements, and the specific one here is this kind of swirly bokeh. If you saw the movie Poor Things, there were a lot of cool shots that were shot this way, and this kind of Petzval effect is now part of the engine. And so over the course of looking ahead, like lens emulation and being able to do these cool real world camera effects in your Unreal Engine renders is a priority for us. So this is an example of that starting to come out, this swirly bokeh. Another thing to mention is ray trace translucency. So for those that do a lot of glass, I feel like this is kind of preaching to the choir, but the ray trace translucency feature was pretty significantly enhanced. I was actually a little bit surprised they didn't call out a little bit more in the keynote. But this is now a feature, so it's a setting that where you used to adjust the ray trace translucency and the post-process volume. There's a new example, or there's new settings, and you'll get significantly better results. Switching over to movie render queue, the mainline item here is called quick render. And so the idea behind quick render is that we wanted to kind of reduce the number of steps it took to initiate a render in Unreal. So the first thing you'll notice is that there's this new little icon. It's right next to the create new sequence icon right there in the toolbar. So it's always accessible, and you'll basically always be able to render. So when you open this up, you can choose between two options. There's quick render, which is now the default, or movie render queue. So if you switch to movie render queue, it's going to open the full queue window. And when you're in quick render, there are four options for what you render. There's rendering the current sequence, which should hopefully be straightforward. Rendering by using the viewport camera in the sequence, which I'll show in a minute, and then a couple of stills options for viewport and camera. So the idea here is that this is for all different types of artists. We have good options for everyone. Right, so the first one is current sequence. So if you hit that and you're on current sequence, it's just going to render it. It's not going to ask you any other questions. It's just going to render the current sequence. And the idea behind this was tying to the animation initiative. We wanted to have something that was kind of like a Playblast tool, but I always feel like when people think of Playblast, it's kind of like a low quality, not a good render. And from the Unreal perspective, we were always aiming to provide a really fast, good render. And so that's what this provides, right? So another aspect of it that is introduced with quick render is there's also this concept of play after render, right? So if you've ever done a render, you don't know where it is. This is now a revolutionary concept of just opening the render that you just did so you can watch it. Quick render does have some settings that you can control, right? So if you scroll down to the bottom, this will pop up in a window that shows the quick render settings. And so this is for quick render using a graph-based configuration. So we provide a default graph. And then what that means is that if you're customizing using the graph, you're also able to use the graph's overrides, variable system to push up overrides, right? So if you're doing a bunch of render and you want to offer a bunch of overrides, you can set up your graph to surface those as variables, and they'll always be available so that you can toggle them as you see fit. Quick Render has some other options just to quickly run through, right? So there's the after render option, like we just showed it playing, but you can also opt out of it if you don't want it to play. And you can also open the output directory just in case you want to copy it out somewhere. Quick Render also has this apply viewport look option. And so there's a series of things here that are meant to be like a kind of what you see is what you get in the editor setup, right? So oftentimes people will get confused, or there might be some issue with visibility or something where like what you're seeing in the editor, when you actually go to movie render queue, you're not actually getting that in the render. And so these are toggles that allow you to opt into various parts, right? So OCIO, if you set up OCIO in the viewport, that is going to be carried over to the output file. Same thing goes for show flags in view mode. Whatever you have set in the viewport, if that's what you want to keep, then this toggle is going to carry it over. Visibility will be handling both actor visibility, like hidden in game versus editor visibility, and also controls level visibility. So sometimes you may hide sublevels accidentally or on purpose in game. Like if you have it visible in editor, that's going to carry over to the render. And then kind of last but not least is this show editor only actors. And so that's a case where like a little bit more animator centric, where they might want to show the control rig gizmos or something like that when they do their render. You have the option to have those appear in the render because you may want that as part of the review. Frame range is also an option to override, so you can use the playback range, the selection range, or you can do a custom. So you can just punch in different frame numbers if you want them to, if you're only wanting to do a subset, just giving you a bunch of different options for what you render. So you are able to also always show that window. Like originally we thought we wanted to have the minimal amount of steps, but if you so choose to, or if you're doing a lot of overrides, it might make sense for you to just pop that window open to make some changes before you actually do the render. So this will just kind of quickly go through an example of using these things in action, right? So I'll set the selection range to a subset. I'll toggle the view mode and then just change it to something else to see it go through, and switch back to the selection range. And now we're going to be rendering this in unlit, just this little subset. Based on the selection range, and it'll play back. We'll quickly go through the play after render settings because movie render queue can render all different kinds of formats at the same time. We allow you to prioritize them, right? So it kind of prioritizes them based on these are all drag and drop movable, but you can basically say, well, if I render both EXR and JPEG, I'd rather see the EXR, or vice versa. You can just reorder theirs. You can reorder those as you see fit. You can also choose to play all of them. So by default, we'll try to play one, but you can also play all of them if you have multiple. And then for each type of output format, you can decide if you want to use the operating system or a custom viewer. So as I've been demoing it, I've been showing it with RV. So this is customized to basically make a big RV command line and play it. You can also switch it back to the operating system, but there are some limitations. Right, so the operating system doesn't know how to play image sequences, so it's only going to open the first frame. And then you're also able to use different options for ProRes versus H.264 versus Avid. Based on those codecs, you may want different viewers to play them, so you can control them separately. Switching over to the next option is this viewport camera in sequence. And this is the one that is, I think, most targeted for animators. What we see a lot is animators like to work in maybe an empty scene. They're really just focused only on their animation, and they work in spawnables, right? So in this case, an animator, we're popping on this animation. It's the only thing in the scene, right? The animator is going to be very focused on this, and they want to be able to look at it from whatever angle. That may or may not be the shot angle. But then they also don't want to add another camera in here because when this gets loaded into the full shot, that camera might conflict. So the idea is basically this will just use whatever angle of FOV that you're seeing in the viewport as the camera that's in the render, right? So in this case, that's exactly what we were looking at. So that's the angle that we're seeing this particular character. But if you move it around, you can look at it at a different angle. Maybe you want to see this side, which is much better. You'll get the same result, right? So the animator can just move this to be whatever angle they want to see the animation at, just press the button to render it. And that's just going to basically be the equivalent of adding the camera to the sequence on the fly while it renders it, and then getting rid of it at the end. On the still side, we have a couple of options for them as well, right? So current viewport is kind of like an MRQized, it's kind of like an MRQized high-res screenshot, right? So by choosing this option, you can position the viewport however you see fit. And then when you render it, it's going to do a full render of just that frame. So kind of the equivalent of like taking whatever position you are in the viewport, creating a camera, creating a sequence, saving it, et cetera, and then rendering it. It's going to save you all those steps, especially if you didn't actually need all of those assets that you might have accumulated along the way. The end result is just a nice MRQ screenshot of whatever it is that you're looking at. The second option here is selected cameras, right? So the idea here is maybe you have a workflow where you place a bunch of cameras. Like I've seen this in a lot of architectural workflows, but you place a whole bunch of cameras that you like of whatever it is that you're looking at. And you can just go select those in the outliner. And then when you quick render with selected viewports, it's going to do the same thing as if it took those cameras, made a sequence, does all that kind of asset management for you without you having to keep those around, and then just puts the render out. So the hope with Quick Render is that it offers like a bunch of different options for people to leverage Unreal's fast rendering much more easily and immediately. Aside from Quick Render, there's some other things we've added which are primarily graph focused. So the first one is time dilation. So you may know me as a product manager, but I'm also an artist. This is some of my finest animation that I've done for this time dilation shot. But time dilation wasn't supported in the graph, and that's something that's been added in 5.6. We've also made a bunch of under-the-hood improvements that deal with how it manages frame ranges, or frame numbers, so to speak. And so that's just something to be aware of, that there were cases where time dilation resulted in gaps in frame numbers, and that should not happen anymore. Adapt resolution is a feature that was actually kind of inspired by the selected cameras option when we added it to Quick Render. It's something that's always kind of bothered me, or like I think is a little bit of an issue with the way we manage different film backs and different aspect ratios, right? So if you use like an HD resolution as we do in this example, right? Output resolution 1920 1080, but in this case, like our aspect ratio is like a little bit cropped. We'll add a letterbox or a pillar box, and so you'll always get the black bars somewhere. And this is fine, this is good. A lot of people like this, but a lot of people don't like this. And then what you end up with is this case where, like, if I don't want the letterbox, then I have to do this math. I have to figure out like what is it, 1920 by what is actually the number. And so adapt resolution allows you to like do that without having to think about it, right? So like I don't have to get the calculator out to figure out that it was supposed to be 817 in this case, right? So automatic will just get rid of the letterbox and pillar box. And then you also have a couple of additional options like scale to width, right? So in this case, we're scaling to width, which was 1920. That's going to be the same as automatic in this case. But if you wanted to scale to height, then that's going to keep the height at 1080, but expand the width to 2538 to give you like the desired output resolution. Right. So if you try this with a portrait example, it's the same deal, right? We're getting black bars on the left and right. But automatic will get rid of those, right? So it'll crop those off. Scaling to width gives us 1920 width, and then it figures out the height. And then likewise, scale to height gives us the 1080 height that we originally asked for, and then figures out the width. And then for square, it's kind of the same deal, right? So when it's disabled, we still get the black bars. Automatic gets rid of the black bars. Scale to height brings us up to 1920 for both width and height, and then scale to height puts us back on the 1080 and 1080, right? So the idea here is that we just want to give you the resolution that you want, give you the resolution that you want without you having to think about it. Okay, so next up in the 5.6 release for Movie Render, we have lawyers, everyone's favorite feature. And so the way where lawyers often come into play is related to codecs, right? So this is a message that I had with the lawyers about how we were trying to figure out how we can offer some more codecs, and specifically that meant MP4 in this case. And so we're really happy to announce that in the 5.6 release, you will be able to make H.264 MP4s natively and directly. So you'll still be able to use the command line encoder if you want, but you don't have to. Like you can just make MP4s directly. It's one of the options, just like JPEG and PNG. The other thing to mention about them is that they will include audio if you have audio in your scene. So audio is embedded in MP4s as well as ProRes going forward. A couple other things to note on the output options front. 5.6 also supports multi-part EXRs, right? So this is going to make EXR layers from UE renders load a little bit more efficiently in your compositing packages if they support it. And then we also now support ProRes on Mac. Like I used to get a lot of questions about how come you don't support ProRes on Mac? Like that's kind of weird. And I agree that it was pretty weird. So we fixed that, right? So you're going to see this across the across the next few releases, but we're going to try to be bringing up Mac and Linux as much as we can to get parity across them, and this is one of them. We want to make sure that there's at least some movie options on each platform, and then especially as our rendering team makes a lot of improvements on those other platforms, we're seeing a lot more people on them, which is great. So we want to make sure that they are able to output media the same way. Next up for Movie Render Queue is high-resolution tiling. So we've spent a lot of time on high-resolution tiling for 5.6. And I think the best way of saying this is when you do a render like this, if you're rendering a 4K render, it'll work, right? Like I'm just rendering one frame of it. It's a reasonable resolution, and it's very likely to fit on my GPU. I'm good to go. Right? If I want to go higher than 4K, then I have to start maybe thinking about tiling, right? So historically, if I try to do 12K, your mileage will vary, right? Like people can run into a lot of issues with memory, especially depending on which GPU they have. And this has been, an area of friction historically. Beyond that, people may want to go higher, right? So like with 16K, you might be in for some sadness. I've been there. That's actually a picture of me. And so this is something we really wanted to address, right? So as part of moving high-resolution tiling and panoramic rendering over to Movie Render Graph, we've also worked really closely with the rendering team to make some improvements to this, so that just the ability to do these super high-res renders is a better experience, right? So some quick boilerplate items, right? So the path tracer supports high-res tiling, but for the panoramic renderer, it's deferred only still. But the main thing in addition to the graph transition is that we've made a lot of improvements to memory, right? So there were some optimizations, some optimizations were identified, some bugs were fixed. And in general, the situation should be a lot more stable. We've also introduced a feature called page to system memory, and what that means is that the renderer can use your system memory in addition to your GPU memory as part of the render, right? So if you have if you potentially have a GPU with less memory, you can use this feature to enhance it. So if you have maybe you have a slower GPU or a smaller memory on your GPU, but a lot of system memory, which is potentially a lot of people, you may be able to get a little bit more high-res mileage that way. Something to be aware of is that using the system memory does have a performance cost, so it won't be as fast as if you just do it GPU only. My advice is to try it with your GPU first, and if you find that you are running out of memory, then switch over, page to system memory. It's going to take a little bit longer, but your render was likely to complete. So in our testing, we're getting good results at things like 24K. And then depending on the scene, depending on the situation, you might be able to do things that are approaching 50K. So this is something that we've been testing. I'm really interested to see how this goes with people, because as people test it across a diverse set of scenes, we have kind of our classics, like Hillside, the Meerkat, and so we're running it through all those and seeing what we get. But and there's nothing like what we learn from people trying to do it for real, right? So. As much as we used to look forward to the UDNs for high-res tiling, you can still send them in, and you can send them in. They'll be like, "Hey, it worked," and I'm legit interested to see how high people can go on this. Anyways, starting at to the home stretch here, we have a number of other graph enhancements to mention in 5.6, right? So frame range variables, that was something that you kind of saw in quick render. But this was something that we added so that basically when you expose the frame range as a variable, it knows how to fall back to what's in the level sequence, right? So you don't have to overwrite it if you don't want to, if that makes sense, right? So sometimes initially what would happen is it would just set your frame range to like 0, 0, which is not what you want, right? So you want to say, use what's in the sequence unless I overwrite it, and that's what's available now in 5.6. We made some improvements to warm up. And so, warm up is kind of a necessary thing to make sure everything loads in your sequence before we go to render. But what we discovered is that we don't necessarily need to run all of the samples for every warm up frame. So now, like if you have, let's say you have 64 warm up frames, it's going to run that warm up without all the samples, and then for the last 4, I think. It dials up the samples for the last 4, and that's all that's necessary to set it up for the actual shot. So in practice, if you are using a lot of warm-up, which is going to be most people, I think, that should save you a lot of time, right? So if you had done like 100, if you had a 100-frame shot and a 64-frame warm-up, then you'd be rendering 164 frames time-wise. This is going to bring that down pretty significantly, and the hope will be that it just speeds up people's iteration time. Component-based conditions, we're starting to get into, people are starting to embrace some of these render layer features, and they're asking for more sophisticated options for conditions. This will give you the ability to, based on an actor that maybe have multiple components, there's a lot of blueprints that are like this, for example, like you may just want to isolate one of the components only for an actor, but show some of the other components and have those be toggled visibility-wise in a render layer. That's now doable in 5.6. We have the ability to crop camera overscan, right? So a lot of people that are doing maybe camera shake or lens, they have calibrated lenses. We have the ability to crop overscan automatically, but it's very similar to other renderers. We have a reroute node, which I never knew I missed until I started making these graphs and helping people make them. But there's a reroute node that now works exactly like it does in blueprints, so that you can kind of arrange your graphs more neatly so that they're more readable. Looking at the graph, this has been a really long-term feature for us, investment-wise, right? So in 5.4, we released it initially as experimental. In 5.5, we bumped it up to beta. And so our goal in 5.7 is to have it be production ready. So we had this. We spent a little bit of time on this quick render stuff for workflow, but in terms of having the graph ready to go, we're really targeting 5.7 for full parity. And so what that means is that end display support will be added. I think that's the main feature of the existing movie render queue preset-wise that isn't supported. I believe we were going to have to also hit motion design as part of this as well, because there's a system to render their different pages. We also want to make some improvements to rendering single layers as well, right? So there are a lot of cases where the graph is maybe a little bit too much, right? So taking some of the ideas from quick render to have it be an experience where you can just set the settings right in the queue window. You don't have to open another preset window to modify the settings. This is something that we're targeting for the next wave as well. And then on the flip side, there's people that are more advanced, right? So oftentimes people that do a lot of rendering overrides across a bunch of different shots, they want to be able to see those, right? So this is an example of something where we might offer a spreadsheet style view that lets you see oh, I have samples for this shot, I have this, I have samples set to this, for that shot, I have samples set to that, and you want to see those all at a glance, maybe with some conditional formatting to see which ones you have overrides on. This is some of the stuff we're thinking about for the queue window. Another thing to mention is rendering while editing your graph configuration. This is something that actually bothers me a lot, right? So something where you're in the graph, you have to go back to the other window to initiate the render. So if you're kind of jamming on your graph and you want to make a bunch of changes, but just render it right there without necessarily having to go back, it's something that we'd like to offer in the next wave as well for the UX. And then kind of last but not least, with the introduction of these custom naming tokens, a very common thing that you want to control the naming of are your renders, right? So for support for custom naming tokens is coming, like based on like what you saw in the cat tools. Essentially, anything that you define in that system outside of MoveRenderCube will be accessible for whatever you want to name your renders. There's a few other things that are related to this that I've been wanting to clean up, like there's some naming for different post-processed material passes. There's a bunch of stuff that you can't quite control the name of fully. That's something that we'll be addressing in the next release. So that's all I've got. I just wanted to end on naming conventions and Taylor Swift. And I think we have some time for questions.